Okay, so let's see how to solve these questions that are part of the extra practice that I share with you. All right, so let's see the first problem here. All right, so for the equation that is shown, it says you have 2 moles of hexane here that are reacting with 19 moles of oxygen, producing 12 moles of CO2 and 14 moles of water. Right, so the first question says, how many grams of water are produced from the combustion of 8 moles of hexane with an excess of oxygen gas? Right, so as I telling you that the excess is the oxygen, you're just gonna have to know what is the amount produced from the 8 moles of hexane. So that's gonna be your initial data. Right, so you have 8 mole of C6H14, that's hexane. And the first thing you have to do, as you have moles, you want to know grams of a different substance, first you have to change from moles of hexane into moles of water, right? So you have that 14 moles of water comes from 2 mole of the hexane C6H14. Okay, so these two numbers are part of the balanced equation. Okay, so here you have the number 2 and the number 14 for water is here with water, right? Okay, so now you're ready with moles of water. Now what's next? What comes next here is that you're gonna change those moles of water into grams of water, okay, using the molar mass. So you have the 1 mole of water contains around 18 grams of water. So after you multiply here 8 times 14 times 18 over 2, it results in 1008 grams of water. Okay, so this is the amount of water that is produced in grams from the combustion of 8 moles of hexane. So that is the first part. So now let's go with the second part of this. The second point says, what mass of oxygen reacts with an excess of hexane and produces 50 grams of CO2? Okay, so now we're looking for the mass of oxygen that produces 50 grams of CO2. So you can start with that 50 grams of CO2. Now you want to get from grams of CO2 to grams of oxygen, right? So the first step is to know how many moles do you get from these 50 grams of CO2, how many moles of CO2 are obtained or are equivalent to this 50 grams. And to do that, you have to use the molar mass of CO2, which is 44 grams of CO2 and 1 mole of CO2. Okay. After this step, it turns out to be the same as the previous question. Okay, so after that, you will have to use the mole ratio here, and then you will have to use another molar mass to get to the final grams that you're looking for, right? So now let's go then here with the mole ratio. And according to the balanced chemical equation, for 19 mole of oxygen, you have 12 mole of CO2, right? Remember that you have to arrange things like this because you want to cancel the grams of CO2 with the grams of CO2, and then the moles of CO2 with these moles of CO2. So now we are located now with the units of moles of oxygen. But now we want to get grams of oxygen. So there is a final step here that is using the molar mass to calculate the number of grams of oxygen, right? So there is, in 1 mole of oxygen, you have 32 grams of oxygen, right? Because you have 2 times oxygen. So now, after the calculations here, you'll be obtaining something like a periodic 57.575750. So let's round it to 58 grams of oxygen, right? Okay, and finally, I didn't tell you, but you cancel the moles of oxygen. So finally, you get these grams of oxygen. Okay, so now let's see the next one. The next is a little bit different because it tells you that you have 25 grams of hexane and 25 grams of oxygen that are placed to react. Okay, and the question is how many grams of CO2 are produced. But now you don't know for sure which of those two numbers or two amounts of grams will be used totally. So we'll need to know which is the limiting reactant first. All right, so let's see how to do that. All right, so to calculate to determine the limiting reactant, you'll have to calculate the amount of moles of CO2 produced by each of both amounts that they're telling you here, that it's 25 grams of C6H14 and 25 grams of the oxygen gas, right? So you'll have to use the first two steps only, the first two conversions, using molar mass for changing to moles, and then the mole ratio changing to the moles of CO2. That's what I'm going to do right now, right? So we'll have the first factor that will be the molar mass. I told you it's 1 mole of C6H14 and 86 grams of the C6H14, right? And then the mole ratio. The mole ratio is 12 mole of CO2 with 2 mole of the C6H14, right? So again, after the calculations and cancel the units that we don't need, we get 1.74 moles of CO2. On the other hand, we have 25 grams of oxygen gas that has the 32 grams of O2 in 1 mole of O2. And the ratio. So the ratio for this, it's 12 and 19. So again, you have 12 mole of CO2. That's not changing from the other one, but now you have 19 moles of O2. So the result, after also cancel out here moles and moles and moles and grams and get moles of CO2, it's 0.49 mole of CO2. So now you will have to compare the amount of moles produced by both reactants. Okay? And you'll notice that this is the least amount of product that is produced. So this is the limiting reactant. So that means that this amount of moles is actually what it's done during the reaction. So now you can convert that amount of moles into grams, and you will be obtaining now the final answer for that question. So using 0.49 moles of CO2 and using the molar mass of CO2, we'll change this into grams. right? So 1 mole of CO2 has 44 grams of CO2. So you'll finally getting 21.56 grams of CO2, right? So now let's go for the last point, is this one. According to the calculations, 86 grams of C6H14 produces 264 grams of CO2. However, in the lab, with this reaction, a student obtained 185 grams of CO2. What is the percent yield of this process? So now you'll have to notice that they are talking about one reactant and two amounts of one same product, CO2. One of them is the theoretical yield. This is this theoretical yield, and the other one is going to be the actual yield, because it's the amount of grams of CO2 that is actually obtaining in the lab during the process. So let's calculate the percent yield. To calculate the percent yield, let me use this part here. So the percent yield can be calculated with the actual yield over the theoretical yield times 100, right? So the percent yield, for this is calculated like this. Okay, it's 185 grams of CO2. That was the actual yield, and 264 grams of CO2. That was the theoretical yield. So this is times 100, and you get 70.08%. And that is the theoretical yield, right? So that is all for this problem, the first problem, this first extra practice problem for your test. Okay, so you have the percent yield, you have a mol-to-mass stoichiometry problem. This was the number 1. The mass stoichiometry problem, that was number 2. And a problem that involves limiting reactant, this whole thing, that was the number 3. Finally, the percent yield was the number 4, right? So that's all for this, and I'm gonna do another video for the number 2.